So today we're going to talk about AlmaLinux and specifically what makes it special, because you may think, oh, it's about some just RHEL clone, so it should be boring to do that. Trust me, it's not. So 2 words about myself. So my name is Andrew. So I use Linux for for many years, since I was 16 probably. And the last 13 years, I work closely with Red Hat sources, doing something with them, some products out of them. And one of the products, and I currently work on AlmaLinux OS, and I'm lead architect from the very beginning. So if you hate something about AlmaLinux, I'm the right person to ask why it is like it is. So, in 2 days, we will celebrate our first public release. It was 4 years ago, and it's AlmaLinux 8.3 beta. It was very beginning, no features, no fancy things, just one architecture. We made a lot since then, but still, even if it's like RHEL derivative, we do a lot of things differently, and today I'll share some insights how we do packages, builds, and releases, how we do images, how we produce security advisories, how we do SCAP profiles, how we add additional hardware support, how we extend virtualization support in AlmaLinux, and how we extend Red Hat lib tool, which is used to migrate to next Red Hat version, to the whole enterprise Linux ecosystem. So all starts with building packages for us. We don't use Koji, we don't use Conflux, we use own build system. One of the reasons why, because we do packages builds for more than 10 years, so we kind of have own vision how to do that and how we comfortable to do that. So we have AlmaLinux build system for that, specifically released for that. And it is open source, obviously, contains of many components. Here are the most main components of it. So it's web server, it's front end, it's build node, sign node, and sign file. What's the difference? So sign node is used to sign RPM packages. Sign file is used if you need to just sign random file with GPG. So it may be like repmd.xml or checksum file for cloud image or something like that. And it uses a lot of open source projects, of course, under the hood. And one of them is Pulp, which I'm very happy about, and I will share later why. We use it as repo storage. So, what can we do? So, we can build RPM packages using mock. Yes, we're special, but not so special, so we don't implement anything here. We can build DNF models with this build system. So we can release these RPM packages built to internal pulp repos and then export them to file system if we need to push it to our mirrors. We collect security advisories information from Red Hat, somehow modify it and then use it in different sources, targets. And we can create own advisories because sometimes we do CVE fixes too fast and we have to do some advisory for them. We can create personal repos. They are corp-like and compatible from client side. And we can do all kinds of SBOM magic. It's a huge topic. We talked about a lot of these before on different places, and it's also in CentOS Connect, by the way, 2 years ago, I think. So if you're interested in SBOM, you should just Google it. Why I'm so happy about Pulp? So we don't use Punji if we need to release some updates. So we use Pulp natively to just add our packages to repos. So here you can see a page. It's public, so anyone can check what we release, when we release, who did this. And so it allows you to check packages, repos, and so on, that were released. And the most interesting thing here. So when we release package, we already know where repos it should go to because we monitor ourselves, we monitor CentOS stream repos. So when we try to release package, it's automatically distributed against repos. So here you can see we have like source repo for source package. We have all the architectures for NUARC package. This particular package is multi-leaf package, so we place it into both 32 bits and 64 bits. And other packages like to corresponding architectures. And here also you can see like upstream, devel, upstream debug info, and so on. So it's super easy for maintainers to release package. So how our pipeline looks like. So we build packages, we run basic tests right after build. So can we install and remove package? Can we check for broken symlinks and other stuff? Then we release these packages to pulp repos. Then we run compose tests. It's the same compose tests that CentOS stream uses, and actually we contributed to it several pull requests last year. So use them against pulp repos. We export pulp repos to file system. Then we push these repos to our primary mirror. And from this primary mirror, we push to our rsync mirrors around the world. I think it's about 430 of them currently. Kind of. Yeah, so next topic. Images. We produce a lot of them and we don't use Kiwi anywhere. It's not something we don't want to use, it's just how we used to do that. So probably we can reconsider it in the future, but so far we don't use it. So let me just explain how we do every type of image here. So ISO images, obviously we use Punji, but we don't use Koji build systems. So, and currently Punji is pretty much tied to this build system. So we had to maintain our own version of Punji, which doesn't use Koji. So to build AlmaLinux from it, you need to have local mirror of the AlmaLinux packages you are trying to compose. But it's not a problem. Our configuration files are obviously also public, so they can be checked. And we provide a guide how to build AlmaLinux ISO images yourself if you wanted. Container images. So starting from here, we usually prefer to use GitHub Actions. So because it's super easy to, for us, it's super easy to contribute for people. So if GitHub Actions are fine for some image, we are happy to use it. So for container images, we have container images repo, and from GitHub Actions, we build packages for every architecture. We push them to Docker Hub, Quay.io, GitHub packages. And we also create pull requests for Docker Hub official library. So obviously, AlmaLinux has official images in Docker. And we're not worried about this, by the way, about vendor lock-in or something, because our own git.almalinux.org is based on Git.ai, so we can switch to our instance. Git.ai is GitHub Actions compatible. So for live images, I also built inside GitHub Actions. So we provide a necessary kickstart file. We provide GitHub Actions pipeline. So it uses AlmaLinux Vagrant boxes. Inside them, we can do whatever we want. And so we built for Intel, we built for ARM. With Live Media Creator tool, we upload ISO images and logs to Amazon S3 bucket. And then we notify everyone interested in our Mattermost chat channel, so they can help us with testing of them. Raspberry Pi images also built inside GitHub Actions, and a pretty weird way probably, because we first start Fedora Vagrant box on Intel, then we run AlmaLinux IRM container on it, and then we do whatever we want. Why we do that? Because Fedora has full QEMU stack, and we need this QEMU user static binary. It's not available to in AlmaLinux, so It's easier to do that, but if it's too special, so it's also possible to use like alternative pipeline on self-hosted runner. But if we want to use GitHub Action Runner, we have to go this way. It's fine for us. And also we build images, we upload them to S3 bucket, and we notify our users that we have fresh build to test. Cloud background images. So we built a lot of them. So it's like OpenStack, OpenNebula, Azure, AWS, Oracle. We don't build GCP ourselves because Google do these themselves, thanks to them. And background boxes for plenty of virtualization types and architectures. We provide background boxes for Apple Silicon Macs to run on VMware Fusion, Parallels, and so on. It's not very good automated right now, so it's some kind of area to contribute. So currently we do OpenStack and OpenNebula images in Jenkins. And for others, we are working on automation this quarter, probably next quarter. So if you want to help us, so feel free to join this activity. Security advisories. So thanks to Red Hat, they are public. So this data about security advisories, it provides in different ways. So it's like security data API, oval feed, which is deprecated already, but still available. New way is VEX documents and RSS feed. So it provides enough information for us. It provides IDs, descriptions, links, and package names, version, whatever. So thanks to this information, we are able to collect them into our nice UI that maintainers can use. So we have all these advisories here. We map these advisories to our build packages, thanks to like, version release and so on. We can review, we can modify title, we can modify description if we need to rebrand something like that. So this works for several years already, so I'm pretty happy with that. And recently, when we started to deviate a little bit, and sometimes we need to release CVE fix earlier than Red Hat does, we need to security advisories for that. So we implemented UI for that, so we can create random security advisory with like title we want, description we want, like links we want, and so on, and release it under our name. So we decided to use the following pattern. So it will be like year, alpha, year, then A, and 3 digits, because like, to make it clear that it's AlmaLinux specific advisory. And then, when we have all this information, we distribute it in different ways. So we distribute it to our errata website, we distribute it to mailing lists, we RSS feed. JSON feed, it's kind of our own format we implemented, so some security scanners use it. Oval feed, and we are not going to deprecate it, by the way, so it will be available. Update info.xml, it's like inserted right into package and repo data and used by DNF. And OSV database, which is kind of Google things, pretty modern, and we're also there. And here is our errata website where you can check latest security updates, choose version, severity, you can find something there, so it's pretty useful. Something also related to security are SCAP profiles, which is a framework to do configuration, vulnerability check, patch checking, compliance, wherever. And I'm happy to say that we are currently merged upstream. So not many distributions are there. We recently merged. There is no version releases yet with our support, so it will be next version. But it's still pretty good. So it's for 9 version currently only, but still. And in RHEL and other like distributions, this data is packaged into SCAP security guide package. So let me talk about how we do that. Usually, CentOS, in this package, CentOS is considered as Red Hat derivative. So it reuses all the tasks, all the checks, whatever from Red Hat. But there are some problems. We need to differentiate them more. So even if you have CentOS, it will have a lot of Red Hat names everywhere. So even if you have CentOS, it will say that it's checking for Red Hat GPG key, for example, but it's not the Red Hat GPG key. And also, like boot, EFI, way is path is different in AlmaLinux, obviously, and other things. So we need to. It's not possible to fix this when you're derivative. Other things is that AlmaLinux already have official guides from CIS and PCI DSS. So why not to show that? So in our profiles, we can rename these profile names to match our names, our release dates, and so on. So they're specific to AlmaLinux, but still compatible, of course, with Red Hat. So if you are running checks on AlmaLinux, it will be exactly the same profiles, exactly the same amount of checks. They will work the same way. Patch is huge, huge patch, 20,000 lines, but it's worth it. Another thing to talk about is hardware support. So after CentOS 7 end of life, users started to migrate and upgrade to AlmaLinux 8, for example, and they noticed that a lot of their hardware doesn't work anymore. Even worse if it's like storage hardware or network hardware, so you can't even install your system anymore on such. There is a repo project that provides a lot of modules for such operating systems, but it's not easy to use it. Sometimes you need to use it as driver disks. It's very hard to use it if you try to upgrade with Elevate or something like that. So it's much easier if this support will be included right into operating systems. And now, when we decided to deviate a little bit, we can do that. So basically, we brought back support for more than 140 devices. All of them are storage devices and network devices. Here's a list of drivers affected. And why it's a repo project here? Because actually we do what they do in their repo. So for this list of drivers, they don't bring any code. They don't update any code. They don't build like something weird. So they just use the same driver code that is already in Red Hat kernel, just unlock some drivers inside of it. That's why we just merged this work into our distribution. So there are two types of patches to make it. Inside Red Hat kernel, there is maintained two lists of PCI IDs. So one of them is disabled PCI IDs and another is unmaintained. So first of all, we need to move all the disabled PCI IDs to unmaintained list to unblock them. So in this case, it will work. You will get notification about this in your kernel logs that this driver is not maintained, blah, 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 but it will work at least. There are also several per driver patches. So to unlock specific patch drivers, you need to patch specific code, bring back some PCI IDs, or maybe some conditions may be there. So we need these extra 6 patches. And this is actually available in any AlmaLinux release. It's AlmaLinux 8, AlmaLinux 9, future AlmaLinux 10. So yeah, we support more hardware, and users love it. So even if we are special enough and still maintain compatibility with Red Hat, we are happy about this, users happy about this, but what we need to do if we need to test more major changes and how to make community test them, generally speaking, how to make even more special. We have an answer for that. So last year in October, we introduced AlmaLinux Kitten operating system, which is specific. It's not AlmaLinux stable, it's a different thing. It's like Red Hat and CentOS Stream, something like that. So AlmaLinux Kitten is based on CentOS Stream. It's rolling distribution. It doesn't have any minor versions, obviously, and supported for the same 5 years. It's used as foundation for AlmaLinux 10 beta. It's already released, and we basically reused 92% of packages directly to beta. So it was very easy release for us. And in the future, it will allow to get updates earlier for AlmaLinux 10 stable version as well. So there are some changes, major changes, in comparison to Red Hat Stream, CentOS Stream in it. So we compiled frame pointers enabled, just like latest version of Fedora, latest version of Ubuntu, and probably Red Hat 11 will be with them, but we already did this to improve profiling and debugging experience. We support secure boot here for Intel and ARM already. We decided to bring back SPICE protocol support because our users ask for that and why it's dropped. I don't know. So in Fedora it works. So we brought it back. Also we brought back KVM virtualization support to IBM Power platform. It was also dropped. More hardware supported, and we implemented also additional Intel V2 architecture option to support all the CPUs since like 2008 that are currently supported in AlmaLinux 9. So to do that, what we have to do? RPM supports these levels like V2, V3, V4 since version 4.19, which is like 1.5 years old or something like that. But the problem is that nothing else supported. So we have to patch about 20 packages right now to make it work, especially like DNF, libDNF, and so on, libsoft, or xpsign. Patched a lot. So we don't have time to discuss all of them. So we have a page with modified packages where you can check all these like list, commits, and so on. And what a surprise, if RPM is supporting these levels, we still need to patch RPM packets because of this. So this is very popular construction, and it's false on V2 because it's not exactly V2. So I think there are like hundreds of packages use these conditions, obviously. So we have to do something about this. We don't want to contribute to 100 packages. I think these decisions should be made somehow, and it should be updated. So currently, the proper way to do that is to use such macros, because this expands to all the versions of this architecture, like without level, V2, V3, V4, and wherever. But there is no packages with this right now. It's supported in latest version of Fedora and CentOS Stream 10, but no one uses this. So we had to patch RPM to just made V2 compatible with such conditions. So our V2, for V2, this works in our case. But in general, it should be like patched globally, starting from Fedora, I think, at some point. And last topic for today is Elevate. So originally, CentOS doesn't support major releases, upgrades, so it's not possible to go from 7 to 8, for example. So 3 years ago, we started a project called Elevate that unlocked this possibility. So Red Hat allows to do that for RHEL, but this tool just doesn't support any other operating systems. We take it, patch it on our side. The cool thing is that we don't only support AlmaLinux there, we support all distributions in ecosystem. So we maintain soft fork of it in our GitHub org. We unlocked support for non-RHEL as I said, and we also unlock support for third-party distributions, repositories, which is also not supported in original lib2. So we support Apple, which is huge because you will never see system in production without Apple, obviously. And also Docker, MariaDB, and so on. So this list can be easily extended. So it's very easy to contribute into Apple, into Elevate. So here's the situation right now, what options you have. So you can go from CentOS 6 even to CentOS 7, then you have to choose where you should go. There are some options like AlmaLinux, CentOS, Oracle, and Rocky. And then go the same operating systems like to the next versions. So currently, we even support AlmaLinux 10 beta. Obviously, it's not stable, it's not for production, but we're ready for that, and we're ready for testing. And this picture is like before today, because today I'm happy to announce that we now support CentOS Stream 10 as well. So this is requested by community. I'm happy to announce it. I'm happy to see some feedback about this and contributions. Thank you. So yes, so contribution. So we maintain two main repos in our space, which is like lib repository. It's fork, it's actions, all the like additional stuff to support third-party repos, to support like additional distributions goes there. Also, we have lib data. It's configuration files, so with third-party repos and so on. So if you want to add third-party repo support, you should go to lib data. Contribution guides how to do guide how to do this also available there. So this is actually what we do every day. So if this is what your heart wants, welcome to our SIGs. We have a lot of them, a lot of places to contribute. We will be happy to see you with us. Thank you.
Thanks a lot for the presentation. You got my attention directly as I saw bringing back KVM hypervisor role on power. But it was in the slide about AlmaLinux Kitten, so it's just like in the rolling CentOS AlmaLinux 10 stream, like whatever. Do you have plan to backport that to AlmaLinux 10 or even back to AlmaLinux 9? Because I would be really, really interested into that for CentOS Infra myself.
Okay, so that's why we did a Kitten. So we collect feedback. So if it's interesting, so yeah, obviously this should go to 10 stable. About 9, okay, we need to discuss. So.
That started as a request from Lance at Oregon State, so talk to him. Yeah.
Thanks. About the V2 microarchitecture thing, one thing you may want to consider is working in Fedora to get the macro fix there. Like that's the kind of change that somebody with Proven Packager can do fairly easily.
Yeah.
Because they can just set all of the packages at once. It would need a change proposal and it would need a bit of work, but that would prep you quite nicely for the future.
Yeah.
It's not that much work, come on.
Okay, thank you.
Maybe a minor correction. A change proposal is not needed for this kind of thing because a mass spec file change that is like a quicker process is also good enough.
Even easier then.
Okay, great. That would be very nice. Yeah, recently we started considering to rebuilding the whole Apple for V2 as well, because as I said before, it's very hard to find any system without Apple. So AlmaLinux for V2 means nothing without Apple for V2, obviously. So Okay, we have a RFC for that. On GitHub.
And all the work for V2, etc., will be clearly a different repository and different ISO image, etc.
Of course.
For the kernel, when you mentioned that you enable back all everything that was disabled upstream in RHEL, is that in the normal kernel so that you can just plain install directly, or is that a different media set?
It's stock kernel.
Oh, just so your stock kernel and AlmaLinux enable back everything. So, okay,
Yes.
good, perfect. Thank you.
Thank you.
Any more questions? Thank you so much, Andrew.
Thank you.